again, 7th graders. Welcome to our first official start to Chapter 7 in the book. In Lesson 7-1, starting on page 352. This is where you can calculate the area, the circumference and area of a circle. The end got cut off there. Maybe I can bring it down here. And a circle. So we can calculate the area and a circle. And I have this nice little target heart here since we are in the month of February. So follow along with your book. Make sure you're keeping track in your vocab and your notes. This is a vocab-rich lesson, so please stay with us and make sure you write down any questions you have. Parts of a circle. This is your book on page 352. Parts of a circle are kind of in depth. So a circle is a set of points. So all of these, if you were to put this on a coordinate plane, these would all just be points put together. Okay? Smartboard's a little off still, so still bear with me. And they're the same distance away from a given point. That given point is the center. Okay? So your center is here. And the circle, every point on the circle is the same distance away from that. That distance from the center to the outside is called the radius. So any point from the center to the outside is the same as the radius. A chord is any segment with both endpoints on the circle. So a chord could be here from end to end, or it could be here from end to end. Okay? That we won't use as much in our language, but we will use diameter. Diameter is a chord, but it's the chord that passes through the center. So your diameter has to go through the center. It can't be like short length like that. It will go all the way through the center, as noted here. Okay, it's noticed by this pink line there. So that's the diameter. One thing to know about the diameter is that the diameter of a circle, is twice the radius. So the diameter equals 2 times the radius. Since the radius is halfway, the diameter is twice as much. So the diameter is the longest chord of a circle. The distance around a circle is called the circumference. On regular polygons, we call that the perimeter. For a circle, it's called circumference. The ratio of a circle the ratio of the circumference of a circle, this is just a little side note, is this 3.1415926. That is the represented by our Greek letter pi, which is one of your vocabulary words as well. 3.141596 is an irrational number that has not found a repeat and has not stopped. So that's something that we kind of round to 3.14, which is the same as 22 over 7. So we use it, approximations of those for pi. What pi really is the circumference divided by the diameter. So circumference can be found by doing or 3.14 times the diameter. We'll learn 2 different ways for circumference, but just to give you a little background on that. And why we use 3.14, if you want to look at a grid, if you had a circle cut into fourths, to find the area of a circle, to say this in a box within a square, and the edges were touching, say, to find the area of this here, you'd be missing this little shed. So it's actually 3.14 because you have to, instead of 4 sides of a square, to count out that part, which is an investigation we might do a little bit more in class. So circumference is the distance around a circle. You can use circumference equals pi times diameter. You have to know what these mean. Okay, again, this is 3.14. The d is for the diameter, the distance across a circle. And circumference is the distance all the way around. This is kind of a mess, so don't write that if you don't want to. Or, since we know that the diameter is twice the radius, we can replace the d with 2r. So if you're given the radius and you don't want to multiply it, you can do 2 times pi times r instead. So both are usable. You will end up using both. So the circumference of a circle, again, is equal to its diameter times pi, or twice its radius times pi. So you're definitely going to want this in your notes. Okay, so find the circumference. Find the circumference of each circle round to the nearest tenth. Remember to read directions really quickly on rounding. You have to remember that this right here is the tenth place. To round to the tenth place, you have to look at the hundredth place, and if this number is 5 or higher, you round up. If this number were to be below 5, like 4 or less, then you just leave the number as it is. Okay, we struggle with rounding sometimes, so make sure we read directions and keep rounding in mind. So let's see what they give us here. So they give us a circle with the diameter of 9. So we're going to use the pi times d. So this is, we write out our formula. Remember to model showing your work. Then we replace d with what we know. We're given here that our diameter is 9. So we're going to replace d with 9. We rewrite again, and the exact circumference. So if you were to say, if you write this in terms of pi, is something you'll hear. In terms of pi, the circumference is 9 pi. Say you were to punch this into your calculator, you're going to use the pi button, so times second pi. Sometimes it's not a second button. Most of the calculator you guys use, it's just a regular button, so you may not need to use the second. You can just push pi, and you'll end up getting this long number that continues. So our directions say round to the tenth. So since 7 is more than 5, we round 2 up to 3. So the circumference is about, and notice since we round, it's about, it's not exact, 28.3 inches. Another one would be if you have a circle and you're given the radius of 7 2/10. So in this case, we may want to use our formula of 2 pi r, since we are given r equals 7 2/10. So we replace r with what we know, and we use the calculator. Otherwise, we would have just written out 14.4. And we work it out, and we do the about, since we rounded to there using the calculator. So the circumference is about, remember, not exact, 45 2/10 centimeters. That's the distance around that circle. So some more examples here. Round to the nearest tenth. So if I try this, so I may do, I'm given, looks like the diameter of 6 feet. So I'm going to use circumference is pi times diameter. I'm going to replace the diameter with what I'm given. So the exact would be circumference is 6 pi feet. But instead, I'm going to use my calculator. And I'm going to use the pi button. So I do 6 times pi. And I get out 18.849555592. Well, my directions tell me to round to the tenths. So I look at the hundredths place right here, and I round nowhere because it's less than 5. So the circumference is approximately 18 8/10 centimeters. Say you were to use your calculator and you did 3.14 instead, you'd end up with just a more rounded number. Okay. Try another one. This time you're given the radius. So you're going to use circumference equals 2 times pi times the radius. So replace the radius. Circumference equals 2 times pi times 11 7/10. So I do that on my calculator. I do 2 times. Sometimes I do the numbers first. So I get 2 times 11 7/10 is 23.4. So that if I wanted to write it in terms of pi, I would write it like that. But since I'm going to work it out with my calculator, I end up with circumference is approximately 773 and a half. The number on the hundredths place was 1, so I don't consider that, and I round to the tenths place, and this unit's in meters. Singular units for distance around. It's a reasonable answer. It's more than my radius. Seems reasonable. The diameter one, this one seemed also reasonable because it was about 3 times as much as my diameter. So thinking about area, quick, a circle can be decomposed into congruent wedge-like pieces. In your book, I'm not going to go super in detail. If you stretch it out, it's half the circumference there and the radius. So since a circle has an area that is relatively close to the area of a parallelogram, you can use the formula parallelogram to work this out. You don't need to put this in your notes if you don't want to, but it's just kind of giving you an idea of how we come to find the area formula of a triangle pi r squared. Since the base times the radius is just like the height, so replacing those things there. If you want to pause and take a look at that, that'd be awesome. We're going to go more in depth on that in class. Area of a triangle. It's the space inside the circle, and it's pi r squared. You need to remember that squaring is a number is multiplying a number times itself. Okay, so it's not the radius times 2. That would be the diameter. It's the radius times the radius. Okay, so squaring is not times 2. It is times itself. Look at that in your notes, and we'll give it a try here. So estimating is a little side note. Estimate the area of a circle and square, and then multiply by 3. So say estimate the area of a circle, square the radius, and then multiply by 3. So we squared 8, we'd get 64 times 3. It would be a little bit more than 180. So given a circle with a radius of 8, we write our formula. We write our formula, knowing that we know the radius. Plug in our radius, 8. Remember, it's 8 squared, 8 times 8, not 8 times 2, which is 64. So this would be the exact area, 64 times pi. But we're going to use our calculator, so 64 times 3.14, and we get 201.1, which is round to the nearest 10th place. So the area of that circle with a radius of 8 kilometers is about 201 1/10 square kilometers. Let's try another one. This time we're given the diameter of 15. So we use, what we have to do in this case is write the formula. We have to cut the diameter in half. Since we know that the diameter is twice the radius, and we know the diameter is 15, what that really means is that we're dividing by 2 to get a radius of 7.5. That might be a challenging part for you guys, so make sure if that's not clear, rewind, go back, think about what you know about diameter and radius. So we replace with half, multiply that through, so this would be my exact area, but I'm going to use the calculator to estimate, and it's approximately 176.7 square feet. Remember, areas in square units, because at this point, when we're squaring, we are doing feet times feet. All right, 2 more examples. This is not giving you a picture, so you're going to have to draw a picture. So you're given a circle on both of these, and of course, they're not to scale. And on this one, you're given a radius, and try to just center, of 11 inches. So since we know the radius, we can plug in area equals, it's pi times the radius squared. So I plug in 11 and I square it. And then I get pi times 121. Well, I know it's going to be over 300 because 100 times 3 would be 300. So I do 121 times pi for the area approximately 380.1, and this is in square inches. Second one, you're looking for a diameter, so straight across through the center of our circle of 5 meters. So since I have the diameter is 5, I need to know the diameter is twice the radius. So that's 5 is equal to 2r. So I divide by 2, and I get my radius is 2.5, or 5/2. So then I do area is equal to pi times my radius squared. So I do pi times 2.5 squared. So then I have, well, pi times 6 and 25/100ths for an area of approximately 19 6/10 square meters. Okay, the biggest issue with this is squaring, okay, and keeping track. So word problem quickly. Suppose you walk around the edge of a circular park and you estimate the circumference to be 470 feet. Based on your estimate, what is the approximate diameter? So this is where you're given the circumference. You're given the circumference, that's why it's highlighted, and you have to find the diameter. So you plug in what you know, replace the circumference, and then you are going to divide by pi. I'm going to show that on both sides. It's like dividing by pi. So you did it on both sides to get d alone. And you get the diameter is approximately 149 6/10. So the diameter of the fountain is about, since it said estimation, 150 feet. So maybe give this one a try and we can visit it in class. It's talking about circular area rug, and this time it's giving you, maybe we'll just do it now. It's giving you the area of a circle. So you know the area is 19.5 square feet, and the question is looking for the approximate diameter. What we know about the area is that it's pi r squared. So we replace area with what we know, 19.5 is equal to pi r squared. Here's where it comes a little tricky. For this one, to get r alone, we have to find r before we can find the diameter. We have to divide by pi on both sides. So we do 19.5 divided by pi, and that's approximately 6.2 is approximately the radius squared. So we take the square root to get r alone. So we take the square root of 6 2/10. So the radius is approximately then 2.5, because it would be 489. And then we have to multiply that by 2 because the diameter is equal to twice the radius. So the diameter is equal to twice 2.5. So the diameter, since this is approximate, is approximately 5 feet. Approximate. Sometimes in these approximate situations, when you know you're going to end up with estimation along the way, I just use 3.14. Things to keep track of, ladies and gentlemen: squaring, not multiplying by 2, taking the square root, not dividing by 2, just writing out the formulas and showing every single step. If you don't show your steps on these, you probably will have a problem. So make sure you do your best, and we'll see you with questions and celebrations of what you know.